Point a flashlight straight down at a globe, then tilt the beam to a shallow angle. The same light spreads over a much wider patch, and it dims. That's exactly what's happening to you right now, and it goes further than you'd think. Because the sun doesn't hit the Earth evenly. It can't, not on a ball that's curved and tilted. Near the equator, sunlight lands almost straight down, concentrated and intense. Near the poles, that same sunlight arrives at a shallow, grazing angle, spread thin. So the equator runs a permanent heat surplus, and the poles run a permanent heat deficit. And heat always wants to even itself out. That imbalance is the engine. Weather and climate are really just the atmosphere trying to move heat from where there's too much to where there's too little. So how does that heat actually travel? Warm air at the equator rises, cools, and spreads out toward the poles high in the atmosphere, then sinks back down around 30 degrees latitude. That sinking, dry air is exactly why the world's great deserts, the Sahara, the Arabian, the Australian outback, all cluster in almost the same band, north and south. Air flowing back toward the equator near the surface gets bent sideways by the Earth's spin, and that's what gives us the steady trade winds sailors have used for centuries. Push a little further, and the picture gets even bigger. Ocean currents pick up where the winds leave off, carrying warm and cold water across entire ocean basins, while mountain ranges and coastlines reshape the wind and rainfall passing through. Layer all of that together, sunlight angle, wind belts, ocean currents, geography, and you get the patchwork of distinct climate zones that decide what can grow and where, all over the planet. So the next time you feel the sun on your skin at a different angle, remember, that simple tilt is the same engine that shapes deserts, rainforests, and everything in between,